So SR latch by using NAND gate truth table we already see basic latch using NAND gate. So what is that basic latch? That means just basic latch using NAND gate. NAND gate. Okay. So we already discussed about this NAND gate, no? So this is yes, yes, and this one is R, and it is connected with an AND gate, and here this will be feedback, and this one will be feedback. This one is yes, R, and QN, QN bar, QN bar. This is present state, and what is the next state? QN plus 1 and QN plus 1 bar. Okay. So if you observe the truth table, yes, R, QN plus 1 and state. Okay. So here 0 0 0 1 1 0 1 1. Okay. What is the state? Invalid state, no? Invalid you got, no? And next this one is set state, and this is reset state, and this is QN, that is memory state. Yeah, so memory state. Yeah. So here latches, if you see the latches, you are getting the outputs in uncontrolled way. Okay. So in order to control these latches, you are going for you need to add a control signal, that is enable. Okay, enable signal to enable or disable the input changes. Okay. So we are going for which latches means gated latches. Gated latches. So gated latches. So here we use a control signal. Okay, we use a control signal. What is that control signal? We are using an enable signal to to enable or disable the input changes. Okay, we can control the outputs by enabling the disabling the input changes. Okay, so this we call as um, gated gated set or reset latch. Set or reset latch. Okay, set or reset latch. So suppose how to so first we'll see the gated SR latch. Okay, gated SR latch. First we'll see the gated SR latch. So just two more NAND gates I'm adding. Two more NAND gates I'm adding. This is yes, and this one is R, and this one is connected with an enable pin. Okay, this is nothing but enable, and this is active means positive level trigger. Okay, positive level trigger enable. So this will be feedback, and this one will be feedback. Okay, so this is a QN and QN bar. So if you see the truth table, so enable yes R Qn plus 1 Qn plus 1 and the next state. Okay, when enable equal to 0, it will be in off state. That means whatever may be S and R, it will be which state means latch state. Latch state. Okay, or latch state or memory state. Okay, so when enable equal to 1 only, it will be activated. Okay, so if you see like suppose when S equal to 0, R equal to 0. So when S equal to 0, R equal to 0. Okay, so S equal to 0, R equal to 0, that means enable equal to what? 1, no? Okay, enable equal to 1 means 0 1 means what is the output you are getting? 1. Yeah, so 0 1 means 1. Okay, so SR latch by using NAND gate, if it is 1 1, which state? When for SR latch by using NAND gate, when input is 1 1, which state? Which state? See and tell me. Yeah, memory state. So that means this is nothing but we can say that this is latch state. Understood? Okay. Next you see like we'll discuss when s equal to 0 and r equal to 1. Okay. So so that means enable is 1 only. Okay. So enable is 1 only. So 0 1 0 1 means what? What you are getting? NAND gate. This is 1. Hmm? Again 1 1 1 1 0. Okay. So for the SR latch, if it is 1 0, what is that state? Reset state. Okay. So that means here when enable equal to 1 and s equal to 0, r equal to 1, this is which state means the reset state. This is reset state. Okay. And next case we will see. Suppose yeah. So I am taking the next case, that is enable equal to 1 and s equal to 1 and r equal to 0. Okay. So s equal to 1, r equal to 0 and enable equal to what? 1 only. Okay. So 1 1 means what you are getting? 0. And 1 0 means 1, no? So that means 0 1. So 0 1 for SR latch. What is that state? Using AND gate. Set state. Yeah, this is set state. 1. This is set state. Okay. And the last case we'll check. Last case. When s equal to 1, r equal to 1. When s equal to 1 and r equal to 1, enable equal to 1 only. Okay. So 1 1 means what? This is 0. And this one is 1 1 means 0. Okay. So when it is 0 0 0 0, what is that state? Invalid state. Yeah. So enable equal to 1 and 1 1, and this is invalid state. Did you understood how I am doing? Okay. So first SR latch. From the SR latch you will get a D latch. Okay. D latch. And next we are using JK latch. From JK latch you will get T latch. Like this you need to remember. Okay. Okay. So next is gated D latch. Gated. We can call as delay latch, delay, or we can call as a data latch. Data latch. Okay. So here how you can design this gated D latch means suppose here you are taking the SR latch only, gated SR latch only. So here this is gated SR latch. So this is S and R. Okay. And it is giving through enable pin. This is enable pin. Um, so this one is connected with an inverter. Then here this input I am giving as D. Okay. And next this is SR latch by using NAND gate. So this one is QN and QN bar present state. And what is the next state? QN plus 1 and QN plus 1 bar. Okay. Okay. So here you see that means here which states we are using, tell me, in this truth table, which states we are using? These two states only. See here, when s equal to 0, r equal to 1. When s equal to 1, r equal to 0. So that means this is connected with an inverter, no? This is connected with an inverter. So that means here you just you analyze. Here if you analyze what you are getting, when d equal to 0, s equal to 0, r equal to what? 1, no? R equal to 1. So enable equal to what? Enable equal to 1 only. So 0 1 means you are getting 1 over here. and 1 1 means you are getting 0. Okay, so this state is nothing but what? So I am drawing the truth table. Previously we got no. So enable D and Qn plus 1 and next state. Okay, so when enable equal to 0, whatever may be the D input, it will be which state means latch state. Okay, when enable equal to 1 only, this will be activated. When D equal to 0, so this state is nothing but what? So reset state, yes. So this is a 0 and reset state. And when this one, when D equal to 1, S equal to what? S equal to 1, R equal to 0, no? So 1 1 means here you are getting 0. Here 1 0 means here you are getting 1. So 0 1 means which state? Set state. Yeah. Yeah, set state. Here 0 1 set state. Okay. So this is a set state and this is set state. Okay. Did you observe anything from this D latch? From this truth table? Whatever the D input is there, that same you are getting at the next state. No. 1 means 0 means 0. 1 means 1. Same thing you are done. So that means we can call this data latch or D flip flop as a sequential buffer. What we call sequential buffer. Buffer is nothing but what? So this is buffer. Okay. When you are giving 0, you are getting 0. When you are giving 1, you are getting 1. Okay, like that. Did you understand? Okay. Next, we'll go with gated JK latch. So gated JK latch, if you understand this latches, you can understand flip-flops easily. Okay, gated JK latch. Okay, so gated JK latch. So one disadvantage in SR latch, what is that? When S equal to 1 and R equal to 1, this is nothing but invalid state. Okay, this is nothing but unused state. Okay, so we are making this as used state in the JK latch, gated JK latch. Okay, so how we are making means just I am drawing the gated JK latch. So this is the NAND gate and this is one more NAND gate. Uh, Here I am giving enable and here I am giving the input J and here I am input K. Okay, and this is one NAND gate and this is one more NAND gate and the output will be feedback like this. Okay, and this is Qn and Qn bar. This is present state and what is the next state? Qn plus 1 and Qn plus 1 bar. Okay, so here what you are doing means one more input you are taking from this. Okay, and one more input you are taking from this Qn. Okay, this is the diagram for JK latch, gated JK latch. Okay, so gated JK latch, if you see, so you have enable J K, next Qn plus 1 and next state. Okay, so when enable equal to 0, J and K are don't care. It will be in which state? Latch state, no? Yeah. So when enable equal to 1 only, this will be activated. Okay. So here, if you see, uh, So when enable equal to 1 means what are the possible combinations? 0, 0, 0, 1, 1, 0, 1, 1. Okay, when enable equal to 1. So here this one is means 0, 0, 0, 1, 1, 0, 1, 1. You are getting same as SR latch only. So this is QN. QN means what? Memory state. Okay, or latch state. Okay, latch state. Okay. One second. This is nothing but latch state. This is latch state, and this is reset state. This is set state. So what you want to do? What you want to check? Shall I check this one or not required? One I will check. Okay, so one I will check. Suppose here you see. Uh, suppose when j equal to 1, k equal to 1. Okay, enable equal to what? 1, no? Okay, so if you take qn as 0, qn bar becomes what? 1, no? I am taking this as present state. So what happens? This will be feedback. Okay, this will be feedback. So 1 and 1 and 1, what you are getting? 0, no? 0, and this will be feedback. uh, 0 will be feedback, 1 and 1 and 1 whole bar. So that means here 1 and 1 and 0 whole bar. So this is 0 bar. This is equal to what you are getting? 1, no? 1. So for 0, 1, what is the state? Set state, no? Yeah, set state. So set state means this becoming 1 and this becomes 0. Okay. So now I'll check when present state is taking as 1. When present state is 1, what is this one? Qn bar is 0. Okay. So I am taking this is j equal to 1, k equal to 1, and enable equal to 1. Okay. Now what happens? This will be feedback. So this is 0. Okay. And 1 will be feedback. So this becomes 1. Now what happens? 0, 1, 1. What you are getting? Whole bar. 0, 1, 1, 1 whole bar. So this is 0 bar. 0 bar equal to what? 1, no? Again, similarly, here 1 and 1 and 1 whole bar. This is 1 bar. 1 bar equal to what? 0, no? So for 1, 0, what is the state? Reset state. Yeah, reset state. So that means here you are getting 0 and here you are getting 1. So if present state is 0, what is the next state? 1. If present state is 1, what is the next state? 0. So this state is nothing but we call as toggle state. What is this state? Toggle state. So whatever the unused state in the SR latch, gated SR latch, we are making as a used state in the gated JK latch. Did you understood? Okay. Yeah. So gated T latch is nothing but gated T latch, gated T latch. Mm, so just J and K are connected together. So J and K are connected together means which cases I am using? Gated T latch. These two cases. These two cases. Latch and toggle state I am using. Okay. So just I will draw the gated T latch. So this is my NAND gate, and this is one more my NAND gate, and enable pin is given. This is enable. Okay. This is J, and this one is K. These both are connected together, and this is given to which one? T. Okay. And this one is given to NAND gate, and this one is given to one more NAND gate. the output will be feedback like this, and here also the output will be feedback. Present state is Qn and Qn bar. What is the next state? Qn plus 1 bar. Yeah. So just we'll see. So enable, next T, Qn plus 1, next state. Okay. So when it is 0, whatever may be the T value, it will be in which state? Latch state. Latch state. When enable equal to 1 only, this will be activated. So when it is 0 or 1. When T equal to 0, what is that state? When T equal to 0, J equal to 0, K equal to 0. Okay. When J equal to 0, K equal to 0, what is that state? Latch state. So this is Qn and this is latch state. Okay. When like T equal to 1, T equal to 1. So J equal to 1, K equal to 1. What is the state? Toggle state. Yeah. So this is Qn bar toggle state. That's it. This is the truth table for the gated T latch. Okay. So first SR latch. From the SR latch, what you will get? D latch. Next JK latch. From JK latch, what you will get? T latch. Okay. Do you understood? Okay. So yeah. So that means if you understand the latches, flip-flops are easy only. So flip-flops means in the place of enable, what you are giving? Latches are level trigger. Okay. So this is positive level trigger. We see no level trigger, edge trigger. Flip-flops are nothing but edge trigger. Understood? Okay. So just I am discussing the flip-flops also. So first flip-flop is what? SR flip-flop. Okay, SR flip-flop. So SR flip-flop, for flip-flop you have characteristics table and next truth table and excitation table and characteristic equation and state diagram. These many are there. Okay. So if you see the characteristic table, okay. One second, please. Hello. హలో యా యా టెల్ మీ క్లాస్లో ఉన్నా క్లాసా ఓకే ఓకే నేను స్టార్ట్ అవుతున్నా మళ్ళీ నేను బయట మీద ఉంటా ఓకే ఓకే సరే యా వన్ సెకండ్ యా so what is characteristic table? Here we already seen SR latch characteristic table, no? Like previously we already seen S R Qn and next Qn plus 1. Okay. Here clock is also there. Clock means what? During the active transition of clock. Okay. So like this active transition of clock. Okay. So what are the possible combinations? 0 0 0 0 0 1 and next 0 1 0 0 1 1 and next 1 0 0 1 0 1 and next 1 1 0 and 1 1 1. So what is the state? Latch state, reset state, set state and invalid state, no? Okay. So from this you can draw the truth table also. So truth table means S R and Qn plus 1 and state. Okay. So just I am drawing the truth table. So 0 0 0 1 1 0 1 1. So this is Qn 0 1 and invalid state. Okay. If you see the excitation table is you will get from the characteristic table only. So how you are getting Qn plus 1. Present state and next state, you need to expect the inputs. You need to get the inputs. That is nothing but excitation table. Did you understand the excitation table? We need to take the present state and next state as inputs. Uh, we need to get the inputs. Okay. So just you see here. When these are the possible combinations 0, 0, 0, 1, 1, 1, 1, 1. Yeah. So see this characteristic table and you will get the excitation table. 0, 0 and here 0, 0. Okay. So when Qn and Qn plus 1 are 0, 0, what are S and R values? Tell me. First one is 0, 0, no? Hmm? When Qn plus 1 are 0, 0, what are S and R values? I'm asking. 0, 0 and next one is 0, 1, no? Yeah, 0, 0, 0, 1. So if you combine, what you are getting? 0 don't care, no? 0 don't care. And when Qn plus 1 are 0, 1, this is second case. What are S and R? 1, 0. 1, 0. And when Qn plus 1 are 1, 0, 0, 1, no? 0, 1. And next you see Qn plus 1, yes, R. Okay. When it is 1, 1, first is 0, 0. Next one is 0, 1, no? 1 second. Fourth case. 0, 0, 1, 0. 0, 0, 1, 0. This is don't care 0. Don't care 0. Okay. This is excitation table. So characteristic equation means how we are getting means from the characteristic table only you are getting. Okay. So what are the min terms? Tell me. 0, 1, 2, 3, 4, 5, 6, 7. Yeah. So you can write a Qn plus 1 equal to what? Tell me the min terms. Hmm. 2. See this min terms. 4, 5. No. Whatever the outputs 1 you need to see. 1, 4, 5 plus don't care of 6, 7. No. So just to draw the K map, get the expression. S R Qn 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, 1, 4, 5, 6, 7. So this is one pair and this is one quad. Okay. So this is S and this is R bar Qn. So Qn plus 1 equal to what? S plus R bar Qn. Did you understand? Okay. Now next state diagram. From the excitation table you can draw the state diagram. So this is present state and this is next state. Okay. So present state and next state. So you are at 0. Okay. You are at 0. Present state is 0. What is the next state? It will be same state, no? What are the inputs? 0 don't care. Did you understand? You are at 0. Next this one I am checking. It will go to next state. What is the next state? 1. What are the inputs? 1, 0. Okay. You are at 1. What is the next state? So next state is 0 and inputs are 0, 1. Yeah. You are at 1. What is the next state? Same state. No? don't get 0. These are the inputs. These are the SR flip-flop characteristic table, truth table, excitation table, characteristic equation, and state diagram. Did you understand? Okay. Next, coming to the D flip-flop. Okay, D flip-flop. First, draw the characteristic table. So, what is characteristic table? D, Qn, and Qn plus 1. Okay. So, Qn and Qn plus 1. So, when D is 0, 0, 0, 0, 1, and 1, 0, 1, 1. Okay. You are getting same thing only. So, that means whatever the D input is there, you are getting. Okay, this is characteristic table. And what is truth table? Truth table is D, Qn plus 1, and state. Okay, when D equal to 0, it is 0. This is nothing but reset state. When D equal to 1, this is 1. This is nothing but set state. Okay, and excitation table, how we are getting Qn plus 1, next T, front T. Okay, 0, 0, 0, 1, 1, 1. Yeah, see here, 0, 0 means what? This is 1. 0, no? 0, 1 means 1. 1, 0 means 0. 1, 1 means 1. So, did you observe anything from this table? Yeah, just it's following the next state. T is nothing but it's following. Just if you remember, if you know this one, just simply write down this value 0, 1, 0, 1 in the D input. Okay. Now characteristic equation means you need to draw the K map. So Qn plus 1 equal to what? Qn plus 1 equal to summation of summation of m of minterms. What are the minterms? 2 comma 3. 2 comma 3. So just you draw the K map, 2 variable K map, D, Qn 0, 1, 0, 0, 0, 1, 0, 1, 2, 3. Okay, 2, 3, and 2, 3, and this is one pair. So what is Qn plus 1? Qn plus 1 equal to D. Qn plus 1 equal to D. Is it fine? Okay. And coming to the state diagram. So from the excitation table, you need to draw the state diagram. So present state, you are at 0. What is the next state? Same state, no? Okay, input is 0. Okay, you are at 0, it will come to next state, that is 1. Okay, again input is 1. And you are at 1, what is the next state? It will come to 0. What is the input? 0. Okay, you are at 1, it will be in the same state, input is 1. This is the state diagram. Okay, can you draw the remaining J, K and T? Okay, yeah. Just try this. If you are not getting, I will tell you. Hmm?